Good morning, AP. Well, here is the magical video to help you with learning those nasty polyatomics. I know when you look at this list and you're like, oh my gosh, how am I going to get this in my head? And Rodriguez says she can do it in 5 minutes. Okay, well, I'm going to teach you those tricks. First of all, this left side right here, these are just common charges for transition metals. No, you don't have to memorize this. I'm just letting you know these are common charges when we talk about the transitions, that you'll usually see these charges a lot. Okay, I am going to talk about mercury, this crazy mercury, number 1 and 2, when I lecture to remind you on how to do ionic compounds, how to use those Roman numerals when we name them. I'm going to deal with this beast on the right side. Okay, so a paper that I gave you, I like to call it Nick the Camel. Okay, so here is the tricks on how to use it. Okay, Nick the Camel, some of these letters are underlined, some are in a different color, and notice the vowels are a different color, the I, A, E, U, O, those are all in a red. And then you see this word ATE, that's in blue. All of these tricks work for polyatomics that end in ATE. Okay, so notice this list. How many polyatomics end in ATE? There's a ton of them. And then you're like, well, Rodriguez, where's the trick for the ITE ones? Because there's ITE, ATE, ATE. Okay, I'll get you those tricks. Okay, so here are the rules. The underlined letter starts with that element symbol in the polyatomic. Okay, so notice right here, Nick starts with that capital N. Okay, remember, because it's underlined. And I got that vowel. Ooh, I should probably be doing this in a different color. And then C and then K. Oops, just right over that guy, N. Okay, so the underlined letter starts with that polyatomic. So that this trick starts with the polyatomic for nitrogen. The consonants, now this one you got to go back to kindergarten, ladies and gentlemen. Consonants are like B, C, D, basically the not vowels. That tells you how many oxygens you have. Well, when you're counting how many consonants, this front letter counts as that. Okay, so just because it's underlined, you got to count it too. And then C and K, these aren't vowels, so I count them also. So I see 3 consonants, so that must mean I have 3 oxygens. Now the number of vowels, which is the red letter, that's the charge. And it's the negative charge, because if you look at this list, these are all negative polyatomics, and there's only 2 that are positive. Okay, so that means -1. Now remember I told you this trick is for the ATEs. Okay, so this starts with nitrogen, so this is called nitrate, ATE. Okay, so here is the biggest trick with the ITEs. When you have polyatomics that end in ATE, that means they have more oxygens. Okay, and if it's ITE, it means it has literally 1 less oxygen. But the cool part is, what do they have in common? They have the same nonmetal that it begins with, and it has the same charge. There's nothing difficult about that. So if I have ITE, that means all I do is just take off 1 oxygen, same -1 charge, and now this is called nitrite. Okay, so that means on our list, we just got done with those 2. Okay, easy peasy. So I'm going to do a couple with you, and then you guys can do some yourself. So Nick the Camel. Okay, let's do the camel one. So it starts with carbon, underline carbon. And now I got to count the consonants. So I got this consonant, M, and then the L. So that means I have 3 oxygens. And then the vowels, the 2 reds, that means it's -2. So who is this? Well, it ends in ATE, and this is carbonate. Okay. Now, notice on the list there is no carbonite. Well, there is a polyatomic out there in the world, carbonite, but we just don't do it in AP. And right there, there's Mr. Carbonate. Okay? Now let's check out the one right below it. This is what really trips students up. What if I put a hydrogen right in front of it? I'm not trying to make an acid. I'm not trying to do crisscross. Okay? I'm trying to make a polyatomic. Well, first you need to remember the definition what a polyatomic is. It's a group of atoms, and they're bonded chemically together, chemical bonding, but they still have a charge. If I'm trying to do ionic and molecular, they don't have charges. Crisscross, charge is gone. But the polyatomics still have to have a charge. So that H plus 1, CO3 negative 2, you literally just add it together. So it's like, pretend like you have like this big old add sign. And I know, sorry, that's a little add sign, but you know what I mean. So I'm going to take that H and I'm going to put that CO3 together, but I'm going to add these charges together. 1 minus 2, it still has to be a polyatomic. So this is called, you name the hydrogen, not hydro. Don't start thinking acids on me. Hydrogen. CO3, that name didn't change, so that's still carbonate. Okay, so you have to remember, ladies and gentlemen, you're going to see hydrogen pop up on this list a couple times. So right here with the phosphorus, there's a hydrogen with the sulfur one. Okay, you're just adding up the charges. So this right here is like if you were to take H and add it to CO3 negative 2 and just add them together. You can even call hydrogen carbonate bicarbonate. Okay, so if you ever heard of baking soda is sodium bicarbonate because it has HCO3 in it. Okay, so we tackled this piece. Okay. Creamy. Okay, creamy right here, which means this polyatomic starts with chromium. So that's why the C and the R is underlined. Now when you're counting the consonants, you got to count both of those. So there's 2 there, and there's 2 there. So I got my 4 oxygens, okay? And I do have 2 vowels sitting right there, so negative 2. So this is chromate. Now you will see on your list dichromate. Dichromate means you have 2 chromiums. Okay, you have 2 chromiums. So if the chromium got doubled, well then the oxygen must be doubled too. Well, it's almost doubled, but it's 7. Don't understand why. I always think it's 8, but it is 7. Okay, but the cool part is if you look at our list for the chromium, they both have the same charge. See, piece of cake. So chromate, dichromate. Okay, so just think of dichromate. You doubled the chromium, but the oxygen almost doubled, but -1. Okay, so there's 2 more. Clam, I can actually get 4 polyatomics in clam. And you're like, woo, 4, here we go. So let's do our rule. I got chlorine, Cl, and I have these 2 consonants, and I have this one. So that's 3 oxygens. Okay, and I only got 1 valve, so -1. Okay, so right there, that is chlorate. Okay, remember our trick. If we take an oxygen off to get chlorite, take an oxygen off, it's still -1. Okay, now you're like, Rodriguez, when you just said you can get 4 of them. Okay, so look what happens. Let's take this chlorite and let me take another oxygen off. Okay, -1. The name is still chlorite, but we add something in the front to it called a prefix. So notice this is chlorite, chlorite. So what we do is we add a prefix called hypochlorite. Okay, now let's take this chlorate and let's do another one, but now let's add an oxygen. So notice these 4 polyatomics, the only thing that changed was the number of oxygens. I'm going to take this name again and I'm going to write it again. But now this time we're going to add a prefix to the front called perchlorate. Okay, so when I do this, ladies and gentlemen, my trick for you is this. Let me kind of highlight it. I write these 2 names twice, and then I write these 2 names twice. okay? And the only thing that's different is that number of oxygens, okay? The very first one has an added name to it, hypo, and the very last one, the fourth one, is per, okay? And you're going to see this when you get to Manly Brad, okay? Manly. This will get you MnO4. You can do the trick yourself, okay? MnO4, -1. And the name of this, because of that 4 right there, is called permanganate. Manganate. Okay? So right here on this list, okay, as you see, where is permanganate? Manganate. Oh, I even spelled that wrong. So sorry. So sorry. I haven't had the morning coffee yet. Okay? It's early. Manganate. Bad, Rodriguez. Bad, Rodriguez. Okay? But that number 4 right there represents that per. Now, before you're like, does that mean every time you see a 4, it's permanganate? No. Not when you get to sulfur and phosphorus. Okay? I'm sorry. Didn't mean to tell you that it always works for 4, but it will work for Brad right here. You can actually get Brad. You can get 4 polyatomics out of Brad. And same thing right here for itch. I can get 4 polyatomics there. Because look at who these elements are. They're the halogens. That cool trick of 4 works for every halogen. Okay, so I can get those 4 right there. So let's go through our list to see which ones we've done. So right here for chlorate, we got hypo and then chlorite, chlorate, perchlorate. We just did permanganate with Manly. And see right here for Mr. Brad, right there, there's Brad. For Brad, I can get BrO3 -1, and that's bromate. And I could do the same trick for bromate and look at our list. Right there. 1, 2, 3, 4. And right over here for itch, I can get iodate. Because it's a halogen. Every halogen does this. The other elements, they don't do this cool trick. Okay? So right there, I can get those 4 for itch, and you can practice it. And right there. See how we're tackling this list slowly but surely. Okay? Super, I can get, I think, about 3 out of this guy. Okay? So super, it starts with sulfur. And I have 1, 2, 3, 4 consonants. Now, before you want to say like persulfate, okay, like I told you, it doesn't work with sulfur and phosphorus. But I do have 2 vowels, which means -2. So there's sulfate. Okay. Now, if I take an oxygen off, same charge, there's my sulfite. Okay. Now, with some of these, we can add some hydrogens onto it. So if I add that H to the front of each one of them, like I said, pretend like you're like adding a little plus sign to it. I want to just add these charges together and add those together. No crisscross. So I would get HSO4. Now 1 minus 2, that means now I'm just stuck with -1. Hydrogen sulfate. Okay. Same thing with HSO3. So HSO3 minus 1. Hydrogen sulfite. Okay. Don't even think of the word hydro, not till we talk about acids. Okay. So right there on our list, we just got this one, and this one, and this one, and this one. See? We got it, ladies and gentlemen. We're getting there. We're getting there. Same thing with this one. I think I can get about 3 or 4 out of Phoenix. Okay, so I just don't remember how many's on our list, but you definitely can get 4. For Phoenix, obviously starts with phosphorus, and I have these 2, plus this N and X. So there's my 4 oxygens. And notice the vowels. We don't usually have a lot of polyatomics with a -3 charge. It's one of the only ones we have. 1, 2, 3, so -3. And there's phosphate. And if I take, oops, that's an A. If I take one off, one of those oxygens, still -3, then I got phosphite. Okay? So PO3 -3. Okay, so there's 2 right there. Now, if I add that hydrogen onto it, +1 right there, +1 right there, Add up those charges. Just add them up. So now I would get HPO4. And what's 1 minus 3? Well, there's negative 2. Hydrogen phosphate. Same thing with this one. HPO3, negative 2, hydrogen phosphite. Okay? Now, I'm like literally running out of room here. So if I go, I'm going to tackle this one again. So if I have HPO4, negative 3, I can make this comes together, I can make HPO4, negative 2, and that's called hydrogen. I'm going to write it down so you can see where I'm going with this. Phosphate. Well, let's say if I add like another hydrogen. So what if I take another hydrogen and add it to that HPO4, negative 2? Okay. So 1 minus 2. So now I got negative 1. But you're going to add those two hydrogens together. So an H plus an H, well, we call that H2. Okay. Don't start putting, you don't even know what probably a coefficient is yet. But you're going to put a small 2 like a subscript and just add those two hydrogens up. PO4 and now negative 1. How many hydrogens do you have? You have 2. And what do we call that in chemistry? We call that di. So then all you do in front of this one, you just put dihydrogen. And it's still phosphate. You can do this trick with phosphite too. Okay, so technically you can get about 6 polyatomics out of here. Just on our list, we have phosphate, phosphite. There's our hydrogen phosphate. And see right there, all we did was put a 2, but the charge just keeps getting less and less negative. So there you go. We just tackled those. For the aspirin one, okay, this is the one that starts with arsenic. Okay, and you'll see it right here on our list. Maybe it's not there. Should be arsenate. Okay, it's not on the list, but we're going to add it on there. It's not one that we have to memorize, but it is one that could pop up on the AP test, okay, which means they'd have to give you some assistance with this. So this is arsenate. Let's count our consonants. We have 1, 2, 3, and 4. Notice I'm not circling the A because that's a vowel. So there are 4 oxygens, and then I have 1, 2, 3 vowels, so that's negative 3. And you can add this to your list. This is called arsenate. Okay? So check out how much we've tackled. Okay? And you're probably like, well, what's left? Okay. Well, we got all this. Coo, coo, coo. Okay? I'm going to circle the ones that we still need some assistance with. Not that many. And then these two. Okay? That's really not that much, ladies and gentlemen. You just got a lot of assistance. I'm just making sure, going through my list again. Okay? We just did this in, I don't even know how many minutes. So, notice the ones that are left. It's the IDEs. Okay? Now, acetate, I'm sorry, I don't have a trick for it. I wish I did. But it's about the only polyatomic that actually has like 3 different elements with different subscripts. 2, 3, 2. Not too bad. And that negative 1 charge. Okay? Sorry, it's just one you just got to know. This guy, trust me, when we get to chapter 15, 16, 17, you're going to have this guy in your head bad because that's all we talk about is arsenic. I want to talk about this hydrogen one. Okay? When you have the element hydrogen, just an element, okay, that's a hydrogen atom, an element. But when you take the one only electron that it has, okay, we just call it hydrogen ion. Okay, what happened is it lost an electron. But who says, because remember hydrogen has 1 proton, 1 electron, and it has no neutrons. But what if you actually let it gain an electron? Okay, so we call that negative 1. Anytime they gain, the ending of the name, where's that hydrogen one? The ending of the name changes. Okay, so we call this hydride ion. So instead of losing an electron, it gained an electron. Okay, nothing difficult about this. Okay, just like when you had oxygen atom, according to the periodic table, it likes to gain 2 electrons. So it's usually O negative 2. And we call that oxide. Okay, so in chapter 2, we're going to revisit these rules again. Okay, so oxide ion. So when they gain, the ending changes to IDE. And I'm just talking about elements. I'm not talking about polyatomics, because you do see that one right there. The one right below it, okay, right here, this hydrogen sulfide. Sulfur is just like oxygen. If you notice him on the periodic table, he's right under oxygen, and he likes to gain 2 electrons. Okay, so get that magical 8. Sulfide. What if I put a hydrogen in front? Same little trick. Like I added those 2 together. Add them together, and then I get HS negative 1. Hydrogen sulfide. If you can name sulfide, you can name hydrogen sulfide. And he's right there. Okay. You can even call it bisulfide, just like some of these with hydrogens. You can call them bisulfite, bisulfate. Nothing wrong with that. Okay. So we tackle those 2. Hydroxide. And then you got this one up here, cyanide. Okay. Never really had a trick for the IDE ones, but I do always show my students these 2. Notice these 2 polyatomics, the ones that actually start or end, that end in IDE. Okay. Cyanide, I always remember the C and the N. Right there. Starts with C, ends in N, slap on the IDE. Okay. And I know it's called hydroxide, ladies and gentlemen, but it's Christmas in reverse. It's not hydroxide, okay? It's hydroxide. OH. Do not be that kid that does that, okay? That means you are thinking about Christmas, ho, 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 way too much, okay? So don't do that, okay? Oxide, let me go back to this one right here, okay? So oxide, let's go to this example. Oxide is O negative 2. But what if I do 2 oxygens with the same charge? Well, we call that peroxide. Okay? And I'm sure, ladies and gentlemen, you've heard of hydrogen peroxide, the brown bottle in the bathroom sink. And he is that formula. Okay? H2O2, hydrogen peroxide. Oxalate, we don't see it too much, but I do have it on your list. Okay? C2O4, negative 2. So, ladies and gentlemen, you got probably 80% of this done with our cool Nick the Camel trick, okay? But eventually when you go throughout AP, you're not even going to need Nick the Camel because we're going to use them so much, you're going to already have them in your brain, okay? But for this first test, this polyatomic test, it's something there that should help you to assist you, okay? Hopefully that was helpful, ladies and gentlemen. We do have 2 polyatomics that are positive right here, so these are going to be tested, okay? Remember, like these, the transitions, I said not tested. So ammonium, I do not want you to confuse it with NH3. NH3 is a molecule. That's a cleaning product. Ammonia, okay? This is an ion, ammonium, okay? Just look at the ending. Water with an extra hydrogen, okay? Hydronium, hydronium. Okay, so those are your polyatomics. Someday, somebody cool out there is going to make a trick for me to share with my students in the future on these circle ones that I just don't have.